You split the bone on the second strike. On a raw diet, a human body requires at least 5 hours of chewing per day just to consume enough calories to survive, leaving almost no time for anything else. So what did the human lineage eat for over 1 million years before fire existed? You're probably picturing desperation, scattered opportunism, hunger managed but never solved. That picture is incomplete. In 2016, Dr. Karen Hardy at the University of York and the Universitat Autònoma de Barcelona analyzed dental plaque from a 1.2 million-year-old hominin recovered at Sima del Elefante in northern Spain. The plaque contained raw animal tissue, uncooked starch granules from grasses, pine pollen, and insect fragments. Every fiber was uncharred. There was no microcharcoal, the standard chemical signature of proximity to fire. In human terms, 1.2 million years ago, before cooking existed, a hominin was eating meat, starch, and insects in deliberate combination, not randomly, in balance. The diet was not improvised. It was a nutritional system, engineered without heat, running on biological mechanisms our bodies still carry today, and largely no longer use. Hammerstone percussion wasn't just cracking bones. It was targeted fat extraction, the highest calorie per effort food strategy available before fire. A hammerstone brought down on the midshaft of a femur creates a Hertzian cone fracture, a cone of force that propagates through the cortical bone wall and splits it cleanly, exposing the marrow cavity. One deer femur yields 30 to 40 grams of fat-dense marrow, more calories per gram than any plant food in the same landscape. This wasn't just a rock hitting a bone. It was a precision caloric instrument with a 2-million-year track record. Raw tuber consumption worked through a different mechanism entirely. Human beings carry more copies of the amylase gene, the enzyme that breaks down starch in saliva, than any other primate on Earth. That genetic duplication almost certainly predates cooking. It evolved to process raw starch. This wasn't just eating roots. It was exploiting a caloric cache that every carnivore in the landscape walked past without knowing it existed. Insects completed the system. Termites contain 38% protein and up to 44% fat by dry weight. Caloric density comparable to raw marrow, and can be harvested in mass during swarming events without any tools. The counterintuitive detail. 2 billion people still practice entomophagy, insect consumption, today, making it one of the only pre-fire dietary behaviors that survived the entire span of human history without interruption. The bone splits. Inside, cold, slightly sweet, faintly metallic. You eat it directly from the shaft. No container, no heat, no preparation beyond the 2 strikes it took to open it. The marrow is dense enough to coat your fingers. You get approximately 35 grams of fat from this femur, roughly 315 kilocalories, in under 3 minutes of work from the moment you raised the stone. But the animal has been dead for 4 days. The muscle was gone when the lions left. You came for what the lions couldn't access, the locked fat inside the bone. Your stomach acid, running at a gastric pH of 1.5, more acidic than that of chimpanzees, more acidic than most carnivores, handles the pathogen load without distress. That acidity didn't evolve by accident. It evolved in scavengers who regularly consumed tissue in various states of decomposition, and it has stayed in every human stomach since. The tubers came before the marrow today. You dug them at dawn, eating some directly, swallowing a small amount of specific clay from the riverbank alongside the most bitter ones. The clay, smectite, high in negative ionic charge, binds to the alkaloids in the tuber's skin, pulling them through the gut intact, preventing absorption. You don't know the chemistry. You know which clay. You know it from the person who showed you, who learned it from the person before them. The insects were opportunistic. A termite mound, disturbed by something larger, swarming. You ate for 8 minutes. Hundreds of termites. More fat per gram than the marrow you are eating now. 3 food sources. 0 fire. Sufficient calories. The controlled use of fire left a consistent archaeological signature by approximately 790,000 years ago. Burned seeds, scorched flint, reddened sediment at hearth sites. What fire replaced was not a single food. It was an entire dietary architecture. The bone processing, the raw tuber strategy, the clay co-consumption, the insect harvesting. A system refined across more than 1 million years of selection pressure. What fire gave was caloric efficiency. A cooked potato yields more than twice the calories of the same potato eaten raw. Cooked meat digests faster, extracting more energy per gram. The gut shrank, the jaw reduced, the colon contracted. Within a few 100,000 years, the body that could sustain itself on raw marrow and unprocessed starch had been replaced by a body calibrated to cooked food's higher bioavailability. The trade was irreversible. Modern humans placed in the same forested environment as the Sima del Elefante hominin. Same foods available, same landscape. Cannot extract sufficient calories from those foods to sustain basic metabolic function. Not because the knowledge is gone, because the gut is gone. We didn't just lose the skill. We lost the biology. You turn a stove knob. They split a femur with a rock and extracted 315 kilocalories in 3 minutes. You avoid insects. They relied on termites for the same fat density as bone marrow, harvested by hand in minutes. You cannot survive on raw food. They built a civilization on it for over 1 million years before the first fire was ever lit. The dependency didn't begin with agriculture or industry or screens. It began with a flame. Everything since has just been the same trade, made smaller. This content is intended strictly for educational and documentary purposes. All historical, archaeological, and scientific references are drawn from peer-reviewed research and named academic sources.